Good afternoon to you all. And my presentation is focused on the current situation of electric mobility in Europe, with the main attention to the two most important markets where the energy group is involved. So we can go to the next slide.
Yes, Giovanni, we move.
As you can see from this picture, Enel is involved mainly in Italy and Spain, and in these two countries we are developing several electric mobility projects, which take advantage of a more general vision involving the concept of smart grids. Smart grids is a new idea of managing the low voltage and medium voltage electricity grid with a different involvement of utilities in the value chain, from a top-down approach, which has been very common during the last century, to a renewed centric approach where the DSO can serve the increasing efforts underlined by global policies on renewables. Is a great opportunity to implement a real third revolution, which could be made concrete with investment in Internet of Things and smart grids. As you can see, the traditional energy value chain, with utility leading in a top-down fashion the value chain, is quickly changing, even as a consequence of international global policies. The role itself of the utility is starting to go outside of the classical energy value chain, and the electric mobility in that sense is a real example of how the utilities can now be sharing their domain with other industries. We can go next. In principle, European governments are pushing for electric mobility as a key instrument to reach the climate goals called EU 2020, which basically means that there is a directive from the European Commission which is setting challenging targets to each national governments by reducing 20% of carbon dioxide emissions by 2020, reaching 20% of renewables injected in the medium voltage grid and low voltage, and increasing 20% of energy efficiency. That's why, in a nutshell, this directive has been called EU 2020. EVs are seen as a key instrument to simultaneously reduce the carbon dioxide emissions in our continent and have a significant impact on the renewables injected in the grid. In order to better integrate renewables in the EV, the smart grids is a key concept that will be overviewed in this presentation. I'm going to the next slide, called EV charging infrastructure features. The basic concept of integrating an EV into the grid is basically using the EV as a dynamic load which could be modulated according to the grid constraints. As a consequence of this, the EVs can be located in the daily load curve, where there is a major possibility of injecting the renewables at local level The final goal of modulating a charging process in this sense is to produce a counter peak in the demand that might be matching the fluctuations of renewables that are being injected in the electricity grid. Go to the next slide. This is the animation of the previous one. Next, okay. The NL EV charging stations. So the purpose of better implementing the electric mobility into the smart grid concept, NL has developed two products. One on the left, which could be charging up to 43 kilowatts. And it is basically a charging pole that allows charging an EV in 30 minutes from 20 to 80%. On the right, you can see the product that has been designed for home charging with a lower output power at 3.3 kilowatts, ideally for implementing integration into the smart grids. The basic principle of this infrastructure is that both products do embed the smart meter designed by Enel. The smart meter is inside the charging station and allows customer to track his own consumption in a way compliant to the rules of the energy market. In this sense, from customer side, the charging stations are already compliant to a multi-vendor approach and to a pay-per-use or a monthly bill payment method. From the distribution system operator side, the inclusion of the smart meter in the charging station allows control of the charging stations. In this way, the charging station could be not a passive node of the electricity grid, but a dynamic node, which could be managed according to the opportunities given by the loads themselves. And that's basically the idea of integrating the vehicle in the grid. And the reason why the charging infrastructure needs to embed a smart meter, needs to embed communication modules to management systems, and needs to allow a remote monitoring so that the charging process could be remotely controlled. We can go now to the next quickly. This is basically an overview of the re-engineering phases of the product. We are now in the third generation of this product, and the product has been installed in Italy and Spain, successfully certifying the integration of the vehicles in the grid by different control schemes. Go to the next chart again. These are some layout pictures of the 43 kilowatt fast charging station. We are now in the testing phase of this product with a medium range EV that is going to be launched in the market by Renault, which is called the Renault Zoe. The critical feature of this product is that it allows a recharge in 30 minutes, and AC charging, mode 3 type 2 as a standard. And that would be our candidate to be implemented in national highways in Italy and Spain. We go to the next. The integration of the vehicles into the grid is allowed by the remote monitoring of charging station and by the real-time management guaranteed by a continuous communication between the charging stations and the management center. So that's why there is no smart charging infrastructure without a central system that could be managing the charging infrastructure itself. The purpose of the EV charging infrastructure central system, as you can see here, is basically to perform the operation and maintenance and customer relationship management processes in order to let the multiple stakeholders to be participating to the electric mobility business without necessarily having a huge starting investment. We go next chart. This is a systems engineering view of how such an infrastructure works, with a real-time communication uplink between the field devices, the charging stations, and the management systems, which is made up of two subsystems, one dedicated for operation and maintenance, and another one for customer relationship management. We can go further to the next chart. Obviously, such a system, which has an acronym of EMM, Electric Mobility Management, has also a subsystem in charge of dealing with the DSO request. The power grid control subsystem is in charge of communicating with the distribution system operator to understand how much charging processes can be allocated in each day and what would be the most suitable time slot in the day where a charging process should be located. So therefore, in a nutshell, an IT infrastructure for electric mobility should have three main subsystems. One dealing with the operation and maintenance in a similar way to other industrial systems engineering matters. One dedicated for customer relationship management, and another one completely new, clear within needs and opportunities coming from distribution system operators. In that sense, the real revolution which is underlined by electric mobility approach is that EVs are connected to electricity grid, and therefore a real interaction between the service providers who are selling services to the customers, the car manufacturers, and the distribution system operator is needed to let the whole value chain properly work. We go to the next. This is an overview of the possible services given by an IT system. You can find the charging station and book. You can receive start and end charging processes messages. You can have dedicated customer applications on your smartphones. We go next chart. As you can see, the smart grid concept here depicted with all possible smart devices connected to the grid include the PV, and the DSO as the responsible party for managing the electricity grid should really have a key role in electric mobility to make EVs a possibly controllable load and impact significantly the renewables in national energy mix. We go further to the next one. This is again another view at systems engineering level of how the electric mobility dedicated IT system should be connected on one side, on the right, with the charging infrastructure, and on the other side, on the grid control systems. We'll go to the next one. The key message of electric mobility is therefore that it's a huge investment, and the huge investment is justified by the possibilities that are opening for electric mobility with a smart charging infrastructure to be installed. Therefore, in Italy, we are following an approach by which the distribution system operator is in charge of installing the charging stations, trying to recognize the charging stations as parts of distribution system operator regulated assets. In this way, the investment for infrastructure is somehow shared among all electricity customers. And the fees for using the charging infrastructure are significantly lowered. The key message for getting electric mobility in a very rollout phase is guaranteeing the interoperability between providers. In this sense, we are testing interoperability between our infrastructure and other providers, like ASIA and HERA. We go to the next one. And we are also testing interoperability at international level. So in Europe, we are conducting projects with EDS, Endesa, RWE, IBM, Siemens, in order to make all charging infrastructure in Europe interoperable, in order to guarantee that our customers can seamlessly recharge among Europe on all charging infrastructure. Can we go to the next one? The project which is in charge of this international interoperability is called Green Emotion, which has the basic idea of performing a roaming of service providers in Europe, so that no matter who is your favorite service provider, you could be allowed to charge everywhere and receive a bill according to the charging processes that you have been performed in the last month. It's a similar concept to mobile phones, but applied to service contracts for electric mobility. We can go to the next slide, which is slide 17. The vision of this international project in Europe is getting all stakeholders on board: service providers, charging infrastructure operator, distribution system operator, to let them cooperate
I think we lost the link. Around 10. 26. We're on slide 17. Yeah, we'll try to get him back. He's in between flights, I think. So.
And the difference between this picture and the next one on the next chart, as you can see, that in this chart, the DSO box, the EVSE operator box, and the EVSE boxes are all marked up in red. So the charging point operator, and the distribution system operator are all managed by the distribution system operator. So the DSO is in charge of installing, operating, and maintaining the charging stations. And basically the service provider can provide services to the customers without investing on the charging points. This is in a nutshell the basic idea of the DSO business model that we are pushing in Italy, because we do believe that the smart grids integration of EVs needs a smart charging infrastructure, which might be costly, and this cost should be recovered by socializing the effort as a general investment for the country economics in order to provide a country-wide, multi-vendor, and a universal accessible charging infrastructure. And if you have further questions, you can find my email on the presentation. There are some other slides, but probably I'm running out of time. So the major concept should have been clear to the audience.